Hello, this is a video response to Ian Juby's episode of Genesis Week called Chopping Down the Tree of Life. I'm going to be addressing this specifically to you, Ian. And, if you feel like responding, I'd love to hear your thoughts on it. I'm going to try to be to the best of my ability, and if you've watched any of my old videos or any videos I've made before, I'm not really good at the respectful thing as much as I try. I am attempting to be a better person. Let's put it that way. So I'm not going to accuse you of being a liar, and I'm not going to accuse you of being fat. I'm going to stick to the arguments you make, and just to see how it all falls out. So I'm going to get started.
And now carried on the Christinema Network. Christinema.com. Christian cinema at its finest. Excellence in pirate broadcasting. We took over Gunkanjima for this week's broadcast so we can continue to bring you the information the anti-creationists don't want you to see or hear, and giving glory to our creator.
All right from the start, I'm going to take issue with a point you make, and I know you introduce your videos this way, so it's part of your standard introduction, which is fine, but you say that you're bringing the evidence that the anti-creationists do not want you to see or hear. Now, I don't want to speak for other anti-creationists or pro-evolutionary biology or whatever you want to call us, but I do want to make a point. I, for one, and I suspect others would agree with me, don't believe that there's any evidence that we would withhold from anyone. Okay, I hope that is clear. There is no scientific evidence that I run across when I say, I hope the Christians don't see that. Or I hope the creationists don't read that or see that, because all of it should be out on the table. To hide any of it is intellectually dishonest. I take strong offense to censoring of information, only presenting, things like out of context quotes or portions of a scientific paper or article in order to claim that it supports your viewpoint when it really doesn't. The whole thing should be presented. I say that's my thought on it. But and I understand that others may disagree with that. But there's again, the point being, there's nothing that I don't want your viewers to see and hear. I would be happy if every one of your viewers, every one of your fans, would read every single article that you present, if that were possible. I realize it's not possible, but there's nothing. Anyway, I'm sorry. I'm flogging this dead horse here.
A couple of stories today involve giving the evolutionary tree of life a good, solid shake to see what kind of fruit falls out of the tree. Now, you've probably all seen Darwin's proposed tree of life, where organisms all branch off from a common ancestor. Now, while this tree of life is portrayed so often in our textbooks, the fact of the matter is there is no tree of life that the evolutionary community agrees upon. In fact, almost daily, there are challenges to that tree of life.
I think that's a little bit of an overreach. Because this is kind of a point. I keep up with information on the tree of life as new findings, new discoveries are made, and everything I've ever seen kind of strengthens the concept and has not in any way challenged the concept of the existence of the tree of life. What you're kind of doing here, you're talking about new findings that somewhat challenge how the minutiae, some of the tips of the branches are rearranged differently with new findings, new information comes in, because science changes and adapts with new information. And there have been some very major sort of shaking the tree of life with things like learning about the early roles of symbiosis, endosymbiosis, lateral gene transfers, these kinds of things. Things that we thought were related, such as all bacteria, turn out to be vastly different, more diversity than all of the rest of life combined, things like that. So new discoveries, but at no point in time do any of these challenge the existence of the tree of life. None of this is saying, maybe there is no tree of life, right? And I know you might argue that that's our bias or something like that, but I want to kind of make this is an analogy. If I go to an apologetics website and I see an explanation for a supposed Bible contradiction, and the author of that article explains that this is the meaning, and this explanation explains it away. And I go to another apologetics website, and that contradiction is explained away with a completely different thing. You'll see this quite a bit. Apologists have different views on why their explanation is correct while the other one. Okay, now all of that. Now, I don't believe the Bible's literally true or anything, but would it be fair for me to take that information and say that daily apologists question the very credibility of the Bible at all? Or because that would be disingenuous of me, because the implication would be, because two apologists have different viewpoints, that they are concluding that the Bible must be false. You're saying that because people who study the origins and diversification of life have disagreements on some of the more insignificant, most of it's pretty insignificant, aspects of that, that they are therefore demonstrating the non-existence or the lack of robustness of the trio life concept or common descent. Does that make sense?
One of those challenges came out this past week regarding some of the alleged oldest fossil beds in the world, the Ediacaran of Australia.
Okay, I need to say, I'm sorry I know I'm interjecting in here before the point is finished, but I do want to say the Ediacaran, I don't, to the best of my knowledge, know anybody that says that it's some of the oldest known fossils on Earth. I kind of think that's a ridiculous claim to make, because to put it in perspective, the beginning of the Ediacaran, and that's not the real famous cool-looking fossils from Australia that are shown, or some from other localities as well. But the beginning of the Ediacaran is 635 million years ago. The oldest known fossils are dated at 3.4 billion years ago. 3.4 billion to 600... I mean, okay, I'm going to try to use... you guys recall way back in the olden days, Carl Sagan, his analogy of compressing time to a 24-hour clock to kind of put it in perspective. I'm going to kind of do that here. If we take the entire history of life based on the fossils, now this is based on the fossil record, the beginning of life 3.4 billion years ago, and to now, to the present day, and compress that to a 24-hour clock, right? You imagine, okay, so 3.4 billion years ago is midnight. Today is, 1 billionth of a second before midnight, 24 hours later, if that makes sense. So putting that in perspective, the first fossils start at midnight. 19 hours, 12 minutes later, 19 hours and 12 minutes later, 4 hours and 48 minutes before the present day, the Ediacaran fossils existed, the beginning of the Ediacaran. So most of the way through your compressed 24-hour period are these fossils appear. So it's really disingenuous, misleading to call them the earliest known fossils. They are some of the earliest, not the earliest, some of the earliest known animal fossils. They're some of the earliest known complex multicellular life form fossils, but they're not by any organization are they the earliest known fossil beds.
The Ediacaran are a fairly famous fossil, and we have a similar bed here in Newfoundland at Mistaken Point. The fossils are considered some of the earliest life, which was supposed to have arisen in the oceans. Gregory Retallack published his studies of the rocks and fossils in Nature magazine, claiming the rocks were once soils and the fossils were lichens. In other words, the fossils are of landlubbers, not sea dwellers.
First of all, I think it's important to restate that in no way are the Ediacaran fossils thought to be the earliest forms of life. Okay, they are not at the base of the tree of life. They are far up the tree of life. They are comparatively recent in the history of life, at least as based on fossils. So again, that's an incorrect statement. But one thing about Retallack now the lichen hypothesis that Retallack has in the Nature article is not new. He's advocated this hypothesis since almost 20 years, as far as I've been able to determine. He's been an advocate that the Ediacaran fossils in Australia were terrestrial and that they were actually lichens, and he hypothesized they were fungi and fossilized wood and these kinds of things, as opposed to shallow water animals, as has traditionally been proposed. And it's important to state that he's been pretty much alone in this, all right? Meaning that it's not, his hypothesis isn't one that's supported. This revelation in nature isn't changing our paradigm of what these fossils mean. It's, Retallack is saying, again, claiming some evidence based on the geology or the geomorphology of the substrate that these fossils are found in, that they are paleosoils as opposed to marine sediments. And there are a number of his critics that for a long time have been showing why they don't believe he's correct. But that's all irrelevant. I got the impression that you seem to think that this changes, like, you know, that this finding is suddenly we're kind of like, you know, burying these Ediacaran fossils, and oh wow, we can't talk about those anymore. They're terrestrial, and that overturns our theory of evolution, or something like that. And maybe you're not trying to imply that, because if Retallack turns out to be correct, and they do turn out to be lichens, those particular ones, there's still other the what is it, vendobionts from other parts of the world, ones that are clearly in marine sediments. It doesn't get rid of the whole worldwide faunal assemblage because these particular ones happen to be terrestrial in origin. And again, the evidence that they're terrestrial in origin, I think, is sketchy at best. It doesn't explain things like the footprints and trails, and there's a few other things, what they call ichnofossils, burrows and such, that have also been found. Lichens, to the best of my knowledge, don't form complex burrows that are morphologically identical to the burrows of, like, priapulid worms. That kind of thing. And priapulid worms don't live in paleosoils on land, or don't live in soil on land. So anyway, I just want to make that point. It's pretty, you're hanging a lot on this concept that, you know, we're all wrong about the Ediacaran fossils.
Did this critter live in the ocean or on land? Retallack even went so far as to suggest that instead of the sea life eventually moving on to land, perhaps it was the other way around. Life evolved on land and then moved to the sea. Such a radical departure from expectations puts a major branch in the tree of life where it was least expected, right at the base of the tree.
To be fair, I cut out a clip where he has a statement from one of the people who dissent or who are opposed to Retallack's viewpoint. So I don't want this to appear as if I'm saying he's only presenting one view. He does at least mention somebody who doesn't agree with Retallack. But again, this is not the tree. This is not the base of the tree of life. This isn't near the bottom of the tree of life in at any way. Maybe if you're talking about just within the animal kingdom, then this is at the base of the animal tree of life, not the tree of life in general. Again, below these Ediacaran fossils, there are the algae and protists and things that are probably sponges that are very well known from long before the Ediacaran.
But let's give the tree another good, hard shake. It was recently discovered that not only do bats and whales share similar design in their sonar systems, but apparently they also share the same genes for the sonar system.
All right. Now, I responded to this claim in a comment on this video, on the original video, and I haven't got a response back yet. So maybe it's a simple error in citation or something. I don't know. But I want to kind of expand or ramble on about a few of these points. First of all, the sonar system of bats and cetaceans is not, the overall effect is similar, but the mechanisms behind it are quite different. Bats, for example, make the ultrasound. The sounds that they emit for their sonar come from the larynx, just like in virtually all terrestrial mammals that make noise, right? They actually have, just like we make noise, just like I'm making noise now, Bats do the same thing. They just do so at a super high frequency. That sound hits an object, bounces back, and in bats comes in through external ears, which you've seen bats, they have big ears, a number of different adaptations and shapes in the ears to transmit that sound. And like in ourselves, and most or all terrestrial mammals, that sound goes through the eardrum, vibrate, does all of those things. Okay, whatever. Okay, I'm not going to get into the details of it. Cetaceans, on the other hand, generate their ultrasounds in their nasal cavities. They don't use their larynx to make these sounds. So they generate the sound in a completely different way than bats do. The sound is focused through mechanisms in the skull and fatty tissue called a melon. It's that bulge on the front of a dolphin's head, for example. Then that sound bounces off an object and is received through fatty tissue in the bottom jaw. They don't have external ears like we do. Okay, they have this fatty tissue, sound transmits there, and then is transmitted to the inner ear. Okay, so to say that they're similar morphologically is kind of is not. It's simply a false statement. But then you make the statement that now the gene sequences are identical or whatever. I'm sorry if I'm miswording how you said that. First of all, the citation you give the Dávalos et al. 2012 paper, which I have and I've read. That paper doesn't say anything about bats and cetaceans having identical gene sequences for their sonar systems. That's not what that paper's about. That paper is about using gene sequences and morphology to distinguish bats within relationships of a single family of New World bats, right? So that paper is only about bat phylogeny, within your bat kind, if you want to word it that way. It's not about comparing bats and cetaceans. Now, the paper does cite another paper about the homologies between, or the similarities between bats and cetaceans, Prestin genes. Now I suspect that's where this is coming from, because that's the only time I can find bats and cetaceans together in terms of gene sequences. And now I'm going to get into a little bit. Sorry, this is going to be a bit lengthy, and hopefully I'll be able to explain it clear. All tetrapods, or as far as I know, all tetrapods produce a protein called Prestin. Prestin is used in hearing. It's part of the hair cell complex in the inner ear of tetrapods. That's reptiles, birds, mammals, whatever. Okay, this Prestin is a family of proteins. There are hundreds of different members of this protein family, all collectively called Prestin, right? And they differ. And as would be expected, they differ based on how to put this. If an organism relies on low frequency sounds, that's what it may say. Maybe that's what it vocalizes. That's what it predominantly hears. We would expect to see Prestin groups of these Prestin within this Prestin family that are better at interpreting, better at transmitting these low frequency sounds. Other Prestins are better at high frequency sounds, right? That makes sense? So it's no big surprise that animals that detect ultra frequency, like bats and cetaceans, would have Prestins that would be of a similar type, right? That's not a big surprise. That's not a convergence that, twists our view on anything. So the paper in that the Dávalos article mentions, and they just mention this as an aside, but they mentioned that it's the Liu et al. Is it 2010, and then there's a Li et al. 2008. I believe I have that correct. Papers that are both about the convergence in this, just in the Prestin. Okay, and that's what the sequence that they're referring to is, that they have arrived at a similar, not identical, but a very similar Prestin configuration for detecting ultra frequency sounds. That's what those papers are looking at. But again, it's not that the ancestors of bats didn't have Prestin, and the ancestors of whales didn't have Prestin, and they both evolved this complex gene sequence that's identical. All mammals have Prestin genes, have a multitude of different Prestin genes that produce different types of Prestin, and bats happen to produce ones that are better at ultra-frequency sound, and so do cetaceans. And the Liu et al. Paper 2010 found that the genes are very similar, meaning that they produce a very similar, not identical, but similar protein. That's hardly stating that the sonar systems, that's not the same as saying their sonar systems have identical genes, right? Do you see the difference there? Or that the sonar systems are morphologically identical or very similar to each other, because they're simply not. The only thing that's similar is the specific protein that detects ultra-frequency sound, and that's no big surprise. I don't think anybody in evolutionary biology or creationism would find that to be... it's not some groundbreaking thing that changes what we know about evolution or creationism, for that matter. It doesn't really change anything in that sense. It's just an interesting little bit of trivia.
We discussed alleged convergent evolution in Crevo Rant number 172, divergent, convergent, parallel, pre-adaptive, reductive evolution.
Yeah, that's another video of yours I think I'm going to respond to. If I recall correctly, that's the one where you discussed the Prieto Gaudino et al. Paper about the fly olfactory systems, and to give you the benefit of the doubt, I'll say that you are strongly mistaken about what that paper says. But that's for a later video.
If two organisms are alleged to have branched off from a common ancestor, and the common ancestor as well as the two organisms all have that same trait, this is called divergent evolution. The organisms diverged from a common ancestor. In fact, we should see a lot of this divergent evolution, were evolution true.
I'm a little unclear as to why you say alleged divergences, considering the fact that there are literally thousands of papers published every single year in molecular and morphological biological journals talking about these divergent events. And in fact, that paper that you're talking about, the one that you're citing in this little portion of your talk, is specifically about divergent sequences and divergences in morphology within this family of bats. You're talking about a paper that documents these divergences, while I kind of implying that there's no such thing, or that they're only alleged, or I'm not sure. At least that's what I take out of this. Maybe I'm wrong.
However, evolutionary theory must now jump all kinds of hoops, calling upon convergent evolution to produce not one, but two miracles. The development of sonar systems that are identical in many ways in completely different animals, each of which develops the systems completely on their own. It takes less faith to believe in a common designer than it does to believe in the evolutionary processes.
I would argue that certain aspects of this kind of backfire on the design concept. And let me kind of explain this. You're talking about a designer, right? A designer who can freely create whatever he wishes to create, or she, it, whatever you want to call the designer, can create at will, right? But what we see in the real world, what we see in organisms, is this jury rig approach. We see organs and systems that are similar to, not identical, but similar to those that are used for a completely different purpose or serve a different function, that are co-opted to do something else. For example, we're talking about echolocation. We're talking about this sonar system of whales and bats. The sound-producing mechanism of bats uses the larynx, like I explained earlier. That they make sounds the same way that terrestrial mammals do. Whales don't do this. Whales have a different system for making sound, and there's a very good logical reason for this. It's simply because the vocal cords, the larynx, the system that terrestrial mammals use for noise generation, is very good at vibrating air, is not very good at vibrating water, right? So it makes sense. So that right there, the sound generating system, I would say is not out of place with your design idea. I mean, the creator designed a different system for making sounds, right? Uses the nasal cavities in the odontocetes. So I would argue that's not. I'm not saying that supports the design hypothesis. I'm saying it's not out of line with it. But the sound reception mechanism. Why do whales hear the inner ear mechanism, the sound, the actual reception of sound in the inner ear in whales is the same as it's seen in terrestrial mammals. They have the cochlea system, they have all of that. They have that inner ear system like terrestrial mammals, but the sound reception, they don't use ears for picking up sound. And there's again a very good reason, because sound travels in water. That wouldn't work in water. For a number of different reasons. One being external ears would be, a drag. They don't streamline and that kind of thing. But hopefully I'm going to make some sense out of this, not just be rambling. But whales pick up sound through their lower jaws. They have a fatty deposits that run from their lower jaw and connect to the inner ear to transmit sound from in the water. But that all in aside, you say, well, that's a great design. And I would argue, yes, it's a great design. But the point of it is that it's utilizing structures that are in place for terrestrial mammals and adapting them to hear underwater, if that makes sense. Why don't whales hear like fish hear? Fish have it's a little bit more complicated, but they have an ear, if you want to call it that runs along the entire side of their body. Mammals don't have that system. Mammals have our lateral line system is coiled up in our inner ear, like in whales. Why didn't the creator make a unique sound mechanism that works better underwater for whales? Why did he use the mechanics, the parts for hearing on land, and then have to go through a bunch of jury rigging to make them work underwater? You see what I'm saying? It's the same argument that's made with homology. I see a lot of creationists will show the whale flipper and the animal hand, a mammal hand, and say, evolutionists claim that these are homologous when, they just have a common designer, ignoring the fact that why do whales have fingers? They have finger bones inside the flipper. Now, they're not loose fingers. They can't grasp. They're not flexible. They're solid, but the finger bones are there. Why would it, if a designer is creating from scratch, a designer doesn't have to build, if you want to call it that, a flipper out of a mammal hand. A designer could design a flipper. Hopefully that makes some sense. You can see the fact that these parts are co-opted from other structures. That's what kind of, I think, flies in the face of this design hypothesis as it applies to homologies. And again, to restate it, as I've done before, these identical sonar systems in bats and cetaceans are not anywhere close to being identical, and the gene homology they're talking about is in the specific protein, the specific Prestin proteins that are similar. So it's, again, hardly the argument being made that they're identical solutions to the same problem, indicating a common designer, kind of falls flat. All right, I'm going to call it quits for part one here. If it's about a half hour, it's close enough. I'm going to try to make a part two in the next few days if I have time. Things are getting a little bit hectic around here. But anyway, hopefully that'll be all right. So I'll hopefully be back soon.